Hi everyone, my name is Atreya Naik, and today I'll be presenting my project, Understanding the Correlation Between Various Environmental Pollutants and Cancer across different geographical clusters of the United States. So, who am I? Well, I'm Atreya Naik, and I live in Seattle, Washington, and I currently attend the Overlake School in Redmond, Washington. I love solving math puzzles, playing piano, playing ultimate frisbee, and doing hiking. And in the picture to the right, this is when I climbed to the top of Mount Inari in Japan. And a special thanks to my mentor, Dr. Morteza Sermati, who really helped me guide me through this project and really helped me along the way. So why is this topic so important to me? Well, around 6 years back, my brother was diagnosed with leukemia, and I'll always be grateful to all the researchers that helped him take advantage of the latest clinical trials. This has helped me to do research in the intersection of math, environmental science, and medicine, which can bring hope to millions of people around the world. And if anyone's wondering, yes, my brother's fully all right now. So my problem statement is, why are certain clusters of the United States more susceptible to harmful diseases such as cancer? And do environmental pollutants play a role in this? So some cancer statistics from the years of 2016 to 2020 are there have been around 8.5 million cases of cancer, 3 million cancer deaths, and cancer is the second leading cause of death during this time period, only exceeded by heart disease. And currently, 1 out of every 5 deaths in the US is due to cancer. And from 2016 to 2019, the incidence rates for adolescents and young adults increased by 0.9% year over year. So currently, there's limited research on why people living in certain clusters are significantly more susceptible to specific types of cancer. And certain clusters are much more susceptible to cancer. For example, New Jersey is much more susceptible to cancer compared to Montana and other states. And Kentucky has a 4 times the incidence rate of lung cancer compared to Idaho, as you can see to the map in the left. So pollution is a key environmental issue in the United States, and pollutant levels are just continuing to rise to uncharted levels and are spiking on the daily. So in the graph to the left, you can see that the global monthly mean of CO2 has risen from 340 ppm to around 420 ppm just in the last 40 years alone. And the global monthly mean of N2O has risen from around 315 ppb to around 337.5 ppb in the last 20 years. So my hypothesis is that there's a strong correlation between air, water, and chemical pollutants and cancer across different geographical clusters in the United States. So for water pollution specifically, we're considering the total pollutant pounds per pounds per year for majors as one of our example statistics. We're considering ozone, CO, NO2, PM2.5, and PM10 for air pollution as some of our examples. And we're considering lead. And we think this all has a linkage to cancer in different geographical clusters in the United States. So why does understanding the correlation between environmental factors and certain geographical clusters really matter? Well, understanding this correlation between environmental factors and certain geographies can potentially help prevent premature deaths from cancer. And as we saw, they're rising 0.9% year over year, like I mentioned in my previous slide. And they can help us understand disease clustering to more extent. And they'll put factory mandates on emissions so that the factory emissions aren't producing as much CO2, so the linkage of cancer and certain population distributions aren't as high. So here's my methodology in this project, and it's determined using a flowchart, which is showcased on the right. So firstly, we started and we found the most comprehensive cancer data and environmental data at cdc.gov and epa.gov respectively. And then we read the data into Kaggle and extensively cleaned the relevant data sets. And then we selected for 1 year. And then for this cancer data set, we created 3 data frames by performing data processing and grouping of the raw data by state. And we considered the 3 columns of state and cancer count, state and population, and we joined the data by state. And then we used a normalized count, which was count times 10,000 over population, to account for population distribution, so that no one state would be overcounted or overrepresented or underrepresented. And then for the environmental data specifically, we created a data frame by performing data processing, and we grouped the data by state, plus air pollutant data, state and water pollutant data, and state and chemical pollutant data. And we joined these mappings together using, and then we join these mappings together for each of the 8 geographical clusters, which we'll discuss in the next slide. And then this helped us determine the Pearson correlation coefficient between the cancer and environmental data across the regions, plot the graphs, and determine regional variability. And then once we did this for 3 years, we were done. So some methodology in this study. So we used the Pearson correlation coefficient formula to measure the strength of our correlation between various air pollutants and cancer across different geographical clusters in the United States. And in the study, any R between 0.5 and 0.7 we considered to be a strong correlation, and any R between 0.7 and 1 was a very strong correlation. So these are the 8 distinct regions that we used. We considered New England, Mid-Atlantic, Midwest, Great Plains, South, Southwest, Rocky Mountains, and West Coast. We didn't consider Alaska and Hawaii because they were too far away from any other place, and they had too different of climates, so we just omitted them from the study. So there's definitely some variability of these pollutants and cancer counts across these regions. As you can see in these maps, the West Coast region had the most days with PM 2.5 and the least days with ozone. The Mid-Atlantic region had more days with NO2, and the New England region had the highest count of cancer per 10,000 people. And as you can see, there's just a lot of variability, with some states having a lot of pollution in certain places and not a lot of pollution in other places. And also, like there's just a lot of variability within the cancer counts and the environmental pollutants across all the regions. So, considering the scope of the data analyzed, we considered 36 different cancer types, 8 regions in the United States, 5 air pollutants, 2 water pollutants, and 5 chemical pollutants. And we created over 3,400 correlation coefficient matrices, and over 1.5 million rows of raw data were processed into valid data frames. And considering some factors that we used, we considered days CO, days NO2, days ozone, days PM 2.5, and days PM 10 for air pollution. We considered for water pollution, we considered total pollutant pounds per year for majors, total pollutant pounds per year for non-majors, and for chemical pollution, we considered lead, sulfuric acid, chromium compounds, benzene, and polycyclic aromatic compounds. So some results of the study. So there was a very strong correlation between certain cancer types and air pollution in certain regions. So specifically, there's a strong correlation between melanomas of the skin and air pollution and PM 2.5 in the Midwest between 2018 and 2020. And this is a snippet of the correlation coefficient, which showcases that in 2018 it was 0.9, 2019 it was 0.8.5, and 2020 was 0.91 for days PM 2.5, which are very strong R values, like we mentioned before. And now considering the correlation between certain cancer types and chemical pollutants, they were also very strong in certain regions. So we saw that there's a strong correlation between colon and rectum cancer and chemical pollution, specifically benzene, in the Mid-Atlantic across 2018 to 2020. So in 2018, it was around R equals 0.9, then it was 0.81, and then it was 0.65, which are all really strong values. Now, considering the correlation between certain cancer types and water pollution in certain regions of the United States, we considered that there was a strong correlation between kidney and renal pelvis cancer and total water pollutant pounds in the Great Plains across 2018 and 2020. So here's some of the results of our study. I'm not gonna go in like discuss all of them with you right now because there's kind of a dearth of time. But yeah, we found really strong correlations in many different regions of the United States, in many different states. And there's just a lot of different types of air pollution, water pollution, and chemical pollution that contributed to that were linked to different types of cancer. And they all had R values above 0.5, and some of them even had R values of 0.9, which is just extremely strong. And then here are some more results of our study. So, kind of concluding, there's a really strong correlation between various types of cancer and environmental pollutants across different geographical clusters in the United States, as seen in the high Pearson correlation coefficient values across the 3-year data from 2018 to 2020. And this is a map showing the distribution of the number of environmental factors that are a strong correlation to various cancers in that region, where the legend can be seen in the bottom right, where air pollution is represented by shaded in triangle, chemical pollutant is a pentagon, and water pollutant is represented by a circle. And these are, we only showcase on the map R values, any R values above 0.5. So now our conclusion is that there's a strong correlation between various types of cancer and environmental pollutants across different geographical clusters of the United States, as seen in the very high Pearson correlation coefficient values. And these correlations were very high for these regions and cancer types across the 3 years of 2018 to 2020 for analysis. The types of cancer and pollutant types vary per region, as shown in the definite variability graphs, 4 definite variability graphs, where the West Coast had the highest days ozone and it had the least days NO2. And certain clusters are much more prevalent to certain types of cancer. And these findings can help shine light on the areas where cancer incidence rate is high and encourage people slash companies in those areas to emit less environmental pollutants into the air in those specific areas to ultimately mitigate the premature deaths that are rising 0.9% year over year from cancer in the United States. And this study could be used to predict future cancer incidence in the United States and then given the pollutants. So, and another special thanks to my mentor, Dr. Morteza Sramadi, who really guided me through this project. And yeah, here are my references. And yeah, here's my appendix for my code, which showcases some of my code for this project. Thank you.
Hi, thank you again for this research. As someone who lives in New York and grew up in New Jersey, they were dark blue on your map at the beginning. I appreciate anyone doing research into this and trying to help solve the problem. So I have a question. What was the hardest part of your research process?
Yeah, so I that's a great question. So I think the hardest part of this research, I think was the kind of coding aspect of it because a lot went into that. So like the data that we chose from EPA.gov and CDC.gov, they were like raw data, not like they were like pre-processed. And we had to do a lot of data pre-processing and data cleaning to get them to a state where they could actually be used. And then that really took a long time. And also, and then after that, like the coding aspect of it was really difficult. As you can see, like this is just some of our code. And we had to analyze over 3,456 correlation coefficients, and that took up a lot of time. And I think those two components were really difficult. And also kind of just understanding like kind of why certain correlations existed and kind of trying to think about that was also pretty interesting. But yeah, I would say those are the two main difficult things in this project.
Okay. And what are the next steps for you now that you've completed your project? Will you continue to build on this? Will you pivot? Do you plan on studying this in college?
Yeah, sure. So some future steps that I have for this project. So what kind of some like future things that can be done are thinking about just a specific correlation because we analyzed over 3,456 correlation matrices, but instead of just doing all of that, you can focus on one, like as one specific one with a really high trend across the 3 years and kind of really understand the causation behind that rather than just the correlation and kind of understand why there was such a strong correlation and maybe do some environmental research and experimental data to understand, to uncover why the Pearson correlation coefficient was very high.
Okay. Well, thank you for presenting. I'm very happy to hear that your brother is better. And again, I really appreciate your work.